I'm going to break this video into two parts. Part one, we'll talk about the x-intercepts, and then part two, we'll talk about the vertex. So the nice thing is, anytime you're asked to find an x-intercept of a function, no matter what the function is, that always means to make y equal 0. And if you think about this for just a second and try to make sense of it, I think it will make sense, because this is not a rule I want you to memorize. This is something I want you to understand. If you know what an x-intercept is, like if I gave you a function here and I said, hey, can you identify all the x-intercepts? And you were like, sure, there's one here, and there's one here, and there's one here, and one here, and one here, then you know that an x-intercept is where the graph crosses the x-axis. So one thing those points all have in common is that if they're crossing the x-axis, it means their y value had to be 0. Because if their y value wasn't 0, they'd be up or they'd be down. They wouldn't be on the x-axis. So anytime we're talking about this, I don't care what class you're in, I don't care how crazy the function looks, if someone's asking you about x-intercepts, that means that y is definitely going to be 0. So to use that to help us, we're going to take this expression, this equation, that we want to find the x-intercepts for, and we're going to set y equal to 0, and then it's going to look very familiar. So now we have 0 equals negative x squared plus 4x plus 21, and I want to solve this equation. And like I said, all I've done is replace the y with a 0. So we're going to factor this thing out, and I'm just going to mention to you guys that the lead coefficient here is negative. That makes for difficult factoring. I'm not saying impossible, I'm saying difficult. And if you have an equation with something on both sides and you have a negative in front of your x squared term, you can multiply both sides by -1 and save yourself a little bit of grief. So if I do that, 0 times -1 still is 0. And then if I multiply this entire side by -1, we get an x squared minus a 4x minus a 21. And now I can go through and factor this. The other nice thing about this particular example, and probably all the ones in this section, is the lead coefficient on x squared is 1. And when that happens, then factoring becomes like much easier. When this lead coefficient's not 1, you got to do the whole like multiply inner, multiply outer, see if the middle parts combine to make the middle, that kind of stuff. If the lead coefficient's 1, you really can reduce factoring down to what multiplies to make this and what adds to make this. Now I'll say, if there's a negative in front of this, or a 2 or a 5, you can't do that. But if it's just an x squared, then figure out what multiplies to make this and adds to make this. And I would definitely attack that by thinking of all the things I can that multiply to make -21. And what comes to my mind almost immediately for 21 is 3 and 7. And I want that to be a -4x, so I want the negatives to win the fight. So I want this to be negative and I want this to be positive. And that definitely works. I'll get an x squared, 3x, and -7x will make -4. That makes -21. Now if I can just figure out what values of x make this equal 0, I now then will know that if x is equal to -3y is 0, so that'll be an x-intercept. And if x is 7, y will be 0, so that will be an x-intercept. That's the x-intercepts. Part 2 of the video talks about the vertex. So check it out, because I'm definitely teaching it differently than I ever have, but I think it makes more sense, so I hope you guys like it.